So if we start thinking about what we've actually done so far, each of the groups have formed a variety of covalent bonds. So we've looked at things in group 4, 5, 6 and 7. Can you quickly think of an example of an element from group 4, 5, 6 and 7? Pause the video and then resume the video when you've done that. So group 4, carbon or silicon might be the two you'd have. Then for group 5, nitrogen or phosphorus. Group 6, oxygen or sulfur. Group 7, fluorine, chlorine, bromine or iodine. How many bonds did each of the group or each of the elements in the group form? Pause the video, then push play to find out the answer. Carbon formed 4 bonds, nitrogen formed 3 bonds, oxygen formed 2 bonds, and the halogens formed 1 bond. So we could visualize this as the part of where we did atoms sort of in displayed formulae. So carbon forming 4 bonds, nitrogen forming 3 bonds, oxygen forming 2 bonds, and fluorine or chlorine forming 1 bond. We could go back through the compounds which we met so far. So we met hydrogen chloride. Obviously I haven't got hydrogen here, but it would look like this. We then had, say, a chlorine molecule, which would have looked something like this. We then had also water, where we had oxygen in the middle and 2 hydrogens. We also had ammonia. You can see for each of these, in all the compounds formed, there are no spare bonds. We then moved on to compounds which contain double bonds. And then for oxygen, obviously we had 2 oxygens with a double bond between them. We also had 2 nitrogens with a triple bond between them, as in 3 single covalent bonds. So these were all the compounds which we formed so far. And you can see when they join together they've used all the bonds. Oh, the last one we had obviously was carbon combined with 4 hydrogens, like so. So we had our carbon here, and again it combined with 4 hydrogens. So we're going to look at some slightly more complicated examples, and it's a bit like a jigsaw puzzle really. We have to think about ways of combining them. So a challenge. Carbon dioxide is made up of carbon and 2 oxygens. What would the displayed formula, so showing the atoms joined together, look like? Carbon, if you look here, forms 4 bonds. Now the bonds could be all on one side, I suppose, like this. Maybe they could also be 3 on one side, 1 on the other side. They can move around. Oxygen has 2 bonds. It could maybe both be on the same side or on opposite sides. It's a bit like when it was in an oxygen molecule rather, and this here was when it was in a water molecule. So have a go at that one. The other challenge is seeing if you can think about a way of combining 6 hydrogens, each which forms a single bond, 2 carbons which obviously form 4 bonds. So have a go at doing that. Pause the video and then come back to seeing how you're doing. We're going to go through that one and that one. So you might want to have a go at this one first, then push play and see how you're doing. So let's start with this one. The carbon needs to form 2 bonds. We could try connecting this oxygen here, see how it does, and we could try connecting this oxygen here. This oxygen here could obviously form another bond, something else, but if we just moved the bond from here to here, we could see we've made carbon dioxide. Each one has formed the appropriate number of bonds with no sort of loose bonds hanging around. With this one here, if we tried connecting 2 hydrogens together, then that would be a completely separate molecule. So that suggests that's probably not a good strategy. So we could try connecting the two carbons together, like so. Now let's try to attach some hydrogens to this. So we take that one, we can put that there. Take this one, we can put a bond in a second. Put a hydrogen here, put a hydrogen here, 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 and draw in our bonds. The second one, we know not to connect the two hydrogens together. Connecting these two together, that's use one of its 4 bonds. Let's just draw both bonds, 4 bonds, so we can make sure we're doing it properly. Got our 4 bonds here. Let's connect some hydrogens to it. So 1 connected here, 1 connected here, 1 connected here, 1 connected here, and we can see we've got 2 bits which aren't joined. But what we could do is just link those 2 together, like so. That would mean each carbon has formed 4 bonds, each hydrogen has formed 1 bond, and everything has formed the correct number of bonds.